Here we are to find the equation of the tangent to the curve x squared plus xy minus y squared plus 4 equals 0 at this point. So first of all, we need to know that the equation of the tangent is given by the equation of a line. So you have y minus y1 equals the gradient of the line, which will be dy on the x times x minus x1. So the points y1, x1 are already given. These are the points. So what is left for us to find is the gradient, the dy on the x. So we just differentiate this, and that will be that. So differentiating x squared, we get 2x. Differentiating this will be a product rule. So first we hold the x constant and we differentiate the y. So we have x constant differentiating dy in terms of x. Okay, so you're having dy on the x. So the second one, we hold this constant, we hold the y constant and differentiate y. So that will be plus y, and differentiate x, you get 1. So that will be y. Minus differentiate y squared, you get, in terms of x, will not be possible, so you multiply through by an identity, that is, so you're having the y squared in terms of x. Okay, so this one will be to be dy squared times dx times dy on dy. So an identity. So we take the y here and the x there. So you'll be having dy squared on dy. So that's, we can differentiate this now because of the y, in terms of y. So that will be 2y, okay, times dy on dx. Okay, so this will be 2y times dy on dx. Then differentiating the constant will be 0, so equals 0. So we bring like terms together, or we can just substitute the value. So let's substitute the value straight away. So x equals 2, so 2 times 2, you get 4 plus 2 times dy on dx plus 4. Then you have minus 2 times 2 times 4, y is 4. So dy on dx equals 0. So we'll be having, you can put this in bracket. So you'll be having this 4 plus 4, 8. So 8. Then 2 minus 2 times 4. These are like terms. So we add the coefficient. So we have 2 minus 8. So we should be negative 6 dy on dx equals 0. Bring like terms together. So try to separate the terms. This goes there. So you're having dy on dx equals, so here you take the inverse, so you get positive 6 dy on x, divide through by 6, so you'll be getting 8 on 6. So it can be broken down, so you have 4 on 3. So that will be the gradient. So we put this back into this original equation here. So we'll be having, this implies that the y minus the y1 is 4 equals the y on the x, which is 4 on 3, times x minus 2. So we linearize all the expressions. So we have 3 times this, 3y minus 3 times this 12 equals 4 times x, 4x minus 8. Bring like terms together, so we take all this term here to the right hand side. So you have 4x minus 3y minus 8 plus 12 equals 0. So we'll be having 4x minus 3y minus 4 equals 0, and that will be our answer. So this is the equation of the tangent. Thank you.